Hello guys, welcome to our class for today. I hope you all are doing good and we're fine. So this is Normal Science Tutors Online, and I'm your online video. I'm your online physics tutor. Um, for today, we are going to be looking at E.m.f, terminal PD, and loss volts. That's what this class is going to cover, right? So please get your writing materials ready so that we can go to the class. But before then, if you have not subscribed to this channel, please click on the subscribe bell. Also click on the notification bell so that whenever we upload a new video, YouTube will notify you, right? Give us a thumbs up, give us a like if you like what we are doing, and then please, we also encourage you to invite your friends so that they can also come and enjoy what you are enjoying on YouTube. Alright, so for this particular class, I've said we are going to be looking at E.m.f, terminal PD, loss volts, and internal resistance of a cell. Okay, so that is what this video is going to cover. Now, if you are ready, please, I want us to go to our class straight away. Okay, so before I talk about the E.m.f of a cell, I want you to recall or go back to the video where we discuss connection of cells. Okay, so if you go to that video, we see that in that particular class we discussed how cells are connected. Cells can either be connected in series or in parallel. They can also be connected, resistors can also be connected either in series or in parallel. Now, when cells are connected in series, their overall E.m.f is the sum of the individual E.m.f of the cell. Okay, so when you add up all the E.m.f, it gives you the overall E.m.f of the cell when cells are connected in series. Similarly to the internal resistance of the cell is also the sum of the individual internal resistance of each of the cell. Okay, then when cells are connected in parallel, the overall E.m.f is equals to the E.m.f of each of the cell, not the sum this time. The overall E.m.f, all the E.m.f are the same. Okay, so assuming you connect three cells that has E.m.f E1, E2, E3 in parallel, the overall E.m.f is E1 is equals to E2 and is equals to E3. So the E.m.f is the same, but the internal resistance is the sum of the reciprocal of all the internal resistances. Okay, and also when resistors are connected in series, their overall resistance is the sum of all the resistors that are connected in series, all the resistors that are connected in series, and the overall PD across the cell is the sum of all the PD across each of the resistance. Okay, and where resistors are connected in series, it is the same current that flows through the whole system or the whole circuit. All right, now when resistors are connected in parallel, their overall resistance is the sum of the reciprocal of each of the resistances. Then their PD is, they are the same, the PD is equal. Okay, the PD across the cell is equal, and the current is the sum of the current through each of the resistance. Alright, so what I've done is just I have gone through a summary of a previous class that we have discussed before. Now, coming to the class that we are in for today, what is E.m.f? The E.m.f for the cell is the potential difference across the terminals of the cell when it is in an open circuit. You know what an open circuit means, and an open circuit means that the cell is not delivering any current, right? That is, the system is not doing any work. So when the cell is not supplying current to an external circuit, or when the work done is driving one column of electricity around the circuit, or the work done is driving one column of electricity around a circuit, that is the EMF of a cell. Alright, so when a cell is not delivering current, if you are looking for the PD of a cell, that is the EMF of a cell, is the PD across the time of the cell when it is not delivering current to an external circuit. Please take note of that. Or it is work done in driving one column of electricity around a circuit. Okay, so take note of that. Then the internal resistance of the cell. Every cell has an internal resistance. The internal resistance of the cell is the opposition to flow of current. Okay, it is the opposition to flow of current. That is the internal resistance of the cell. Then the terminal PD is defined as the PD between the terminal of a cell when it is delivering current to an external resistor. So when you say terminal PD, it means the PD across this external resistor. Because if this is a cell, this is the battery, this is a cell, right? Then this is the internal resistance of the cell. This is an external resistor. This is the current that is flowing. So the PD across this external resistor is called terminal PD. The PD across this internal resistance is called lost volts. Please, you need to take note of this so that when we are solving some problems that will be coming up shortly, you will know how to apply these definitions that I just gave. Okay, the PD across the internal resistance is called lost volts. The PD across the external resistor is called what? Terminal PD. Please take note of that. Alright, so these are the equations that you will need to solve any problems on the E.m.f, terminal PD, and lost volt. Okay, so as I've said, the E.m.f of a cell is equals to the potential difference across the external resistance plus the potential difference across the internal resistance R. That is the total EMF. So which means that EMF is equals to terminal PD. Don't forget, I said terminal PD is the PD across the external resistance, and lost volt is equals to the PD across the internal resistance. That's what I said before. So you can actually write them alphabetically, that E is equals to capital V plus small v, because these two, they are also PD. So we use terminal PD, capital V, and small v for. Okay, so you know that from your equation, from your Ohm's law, where current is equals to voltage over resistance. So voltage is equals to current times resistance according to the Ohm's law. So you can actually substitute IR, which is current and resistance, into these PDs to give you this plus this. Okay, so if you do that, you can actually bring your current out to have this equation. Now if you make your current the subject of this formula, you are going to have that current for that setup is equals to the EMF all over the sum of the external resistance plus the internal resistance. Okay, so the sum of the value of the external resistance plus internal resistance, this gives you the equation of finding the current in the cell. Now, besides that, you can make any of these variables the subject of the formula for you to be able to find maybe the value of the external resistance, or the internal resistance, or the EMF of the cell, as the case may be. So please take note of this equation, because this equation I'm going to use to solve a lot of problems. So as I've said, the PD across the internal resistance is equals to lost volt, and that is what I have put here. Then the PD across the external resistance is equals to terminal PD. Okay, so if you look at this equation 1, you can write this equation like this. This equation can be written in this format. This equation 1, can write it this way. Now when you write it this way, it means that you are making your lost volts the subject of this formula. Okay, or you can write your terminal PD to be E minus V, as the case may be, and this you can write in this format. Okay, so it depends on the equation that you want to solve. You can use any of this equation to solve. Depending on the equation that you are given, you can use any of this equation to solve for you to arrive at your answer. So without wasting more time, I will solve some problems now so that we'll be able to drive home this point, so that we don't talk too much on this. So let's see some problems. Alright, so this is a sample question that we need to solve. It's question number 1. It says that a battery of E.m.f 24 volt and internal resistance 4 ohm is connected to a resistor of 32 ohm. What is the terminal PD of the battery? This is actually an objective question, but if assuming it's a theory question, it is always advisable that you should be able to draw the setup. Is that okay? It's always advisable that you draw the setup. Okay, so this setup will look like this. Please pardon my drawing. My drawing might not be too perfect because of this what I'm using, but please, you can also do your drawing to make your drawing to be better than what I have. But I'll try as much as possible. Okay, so you have something like this as your setup. Okay, so this is your A, okay, of E.m.f 24 volts. That's what is given to you. It's 24 volts. Then you have your R, which is your internal resistance to be 4 ohm. Then you have this your external resistance to be what? 32 ohm. Okay, all right. So this is basically what you should have as your setup. Fine. So this is what you should have. Now, for this particular question, you will be given E. This is your E.m.f that is given to you to be 24 volt. I have represented it already on the diagram for you. You are given arrow. Arrow is given to you to be 4 ohm. I have represented that also in the drawing. And then we are giving capital arrow to be equals to we are giving the capital arrow to be equals to what is that? 32. Sorry about that. 32 ohm. Okay, so for you to solve this problem, first of all, you will have to find the current that is flowing through this setup. So from the equation we got before, current is equals to E over arrow plus small arrow. So if you substitute into this equation, from all the values we have at 24 all over what? 32 plus 4. So I think that gives us 24 over 36. Okay, so by the time you do your division out, you are going to have that I will be equals to what? 0.67 amp. So this will be your current. Now we said that the terminal PDV is equals to what? Current times what? External resistance. So substitute into this value, you have 0.67 multiplied by the external resistance, which is 32, multiplied by 32. Okay, so you can work that out. So you have 21.3 volts. Okay, so you have 21.3 volts as your terminal PD. Okay, so I hope this one is clear. Or you can also use the other formula we got. We said that V is equals to E minus lost volts. Okay, so E in this particular equation is your 24 minus your lost volts. Your lost volt is current times internal resistance, which is 4. Okay, so if you work this out, you are going to have 24 minus 2.67. So when you do this subtraction, you have 21.3 volts. So okay, so you can use this, but the first thing that you need to take note of here is that you must first of all do what? Find the current that is flowing through the setup. Once you have gotten the current in terminal PD, you can either use this or use this. All right, so I hope that is clear. Fine, this is another question that we also need to look at. And as I said, for any question in this particular topic, it is always advisable that you draw the setup. If you are able to draw the setup, you see the picture of what is happening clearly, and that will just make your calculations to be very easy for you to go through. Is that okay? Because some of these mini writings, they are just there just to confuse you. So your ability to picturize what the question is saying and then present it properly in a diagram gives you a score. Even if it is a theory question in WAEC, if you can represent the question in a diagram, you already got a score from your examiner, because it shows that you understand what the question is saying. So the little that you will now solve will add up to whatever you have to score in your examination. So please take note of this simple trick that students use to score high in examination, especially when you are dealing with questions that require that you produce a drawing. Please try as much as possible. Don't avoid the drawing. Don't avoid the drawing. That drawing carries a mark in an examination. Okay, so this question says that a battery made up of two cells joined in series supplies current to an external resistance of 5 ohm. If the EMF and internal resistance of each of the cell is 0.6 volt and 3 ohm respectively. Are you following? Say calculate the current flowing in the external resistor, then the terminal PD and the loss volts of this setup. So I would like that we first of all represent this in a drawing, right? So as we drew in the other case, please pardon my drawing. It said that the cells are connected in series, so I'll try to draw that in series. Please don't mind my lines. My lines might not be too straight, but please just get the information that you need to get from this. Alright, so this is basically how the setup should look like. Okay, so current, then say this is E. Okay, so then you have your internal resistances here, then you have your external resistance. Okay, so this external resistance, they said it is 5 ohm. Okay, then this one, they said each of them is 3 ohm respectively. Then this one too, they say each of them is what? 0.6 volt, 0.6 volts. So this is your drawing. If you're able to represent this in a drawing like that, you already have a score from your examiner. You have a score already from your examiner. Now from this setup, we can now see that the total E is equals to what? Since they are in series, total is E1 plus what? E2. Okay, So that gives us 0.6 plus 0.6, and that's equals to 1.2 volts. This is your total EMF. And also the total internal resistance of the cell is equals to what? 3 is sum of the two to 3 plus 3, and that gives us 6 ohm. They have given you external resistance to be equals to what? 5 ohm. So from this place we can find the current flowing through the setup. Okay, current flow is equals to E all over external resistance plus internal resistance. Substitute into these values. We have 1.2 all over 5 plus 6 all over 5 plus 6. So if you work this out, you are going to have 1.2 divided by what? 11. So the current that is flowing through this setup we are required to find is equals to what? 0.11 amp. Okay, so that is the current. Now you are asked to find terminal PD. Well, we said that terminal PD is the PD across what? The external resistor. So terminal PD is equals to current times what? The resistance of the external resistor. So which is 0.11 multiplied by 5. Okay, so when you work that out, you have 0.55 volts. Loss volts, as we have said, is equals to the PD across the internal resistance. Okay, so that will be equals to 0.11 times 6, and that gives us 0.66 volts. So you see how easy these questions are, but when you look at the writer, you think that, oh, this question will finish me, right? So but if you follow through, you will find out that the questions, they are not as difficult as they look. All right, they are not as difficult as they look. So this is another way of applying this formula that we just discussed. This is another question, very interesting. It says that a cell can supply currents of 1.2 amp and 0.4 amp through a 4 ohm and a 14 ohm resistors respectively. Calculate the internal resistance of the cell. This is a jam question, so if you do a jam, you can only do a sketch. You might not need to draw, but for me, for this particular question, for ease of understanding, I will just do the sketch so that you understand what they are saying. So they said a cell can supply current to, please pardon my drawing. Okay, so a cell can supply currents to a 4 ohm and a 14 ohm resistor. Okay, so this is the cell picture. Resistor, this is 4 ohm, as the case may be. This resistor is 40 ohm, as the case may be. Then this is let's say 2, and this one current here is let's say current here I here is 1.2 amp. Current here is equals to 0.4 amp. Now you are asked to find internal resistance, which is R. Okay, this is what you have to find, the internal resistance, which is small r. That's what you have to find. So indeed there are two cases here. Okay, but before that, remember that this is the formula that you are applying, that I is equals to E all over external resistance plus internal resistance. So if internal resistance is small r, in first case they said that, let me just put this as A, the current for this particular first case is equals to 1.2 amp, and then you don't know the external resistance, but you don't know the internal resistance. Okay, so this will be equals to I equals to 1.2 is equals to E all over 4 plus R. So let's just take this as 1. Then B, second one is 0.4 is equals to E all over 14 plus R. So take this as second equation. Okay, so this equation you can actually make E the subject of your formulas for the two, so that you have that for the A, have that E is equals to 1.2 bracket 4 plus R. Then for the B, you have that E is equals to 0.4 bracket 14 plus R. Okay, so you have this two instances. Now equating the two equations 3 and 4, if you equate them together, you have that 1.2 4 plus R is equals to 0.4 14 plus R. So this has automatically become a mathematical equation, right? So you can just solve this out. 1.2 times 4 is equals to 4.8 plus 1.2 R is equals to 0.4 times 14 is equals to 5.6. 5.6 plus 0.4 R. Okay, so here you cannot take like terms, right? So collect like terms, you have that 5.6 minus 4.8 is equals to 1.2 R minus that's a minus sign there, minus 0.4 R. Okay, so this gives you 0.8. We'll give 0.8 equals to 0.8 R. So make R your subject of formula by dividing by 0.8 on both sides. You have R will be equals to 0.8 all over 0.8. Okay, so by the time you do that, you are going to have 1.0 ohm. So your R, which is the internal resistance, equals to 1.0 ohm. Alright, so you can see how I went about this question and how we are able to arrive at this. Alright, so These are different ways of solving different questions as the case may be. Alright, so before we leave, I want you to solve these problems that are on your test your understanding page. So I hope this is clear and it is easy to follow through. Okay, so this is your test your understanding page. Please try as much as possible to solve all these problems. They are just like what we have done. They are not difficult. They are just like what we have done. Okay, so this one say a battery of E.m.f 12 volts and internal resistance R 1.5 ohm is connected to an external resistance of 3 ohm. Calculate the current flow in the circuit. This is what we have done already. The PD across the 3 ohm resistance and the internal resistance. We have done this one. This is terminal PD and this is loss volts. The terminal voltage of the battery is same thing as the terminal PD. The reading of a voltmeter connected across the battery terminal in open circuit. This reading of a voltmeter connected across the battery terminal in open circuit is equals to what? It is equals to the total EMF. Remember that we define EMF as the PD across a cell when it is in an open circuit. So you should remember those definitions and then know how to solve this problem. Then this one say an electric bed takes a current of 2 amps from a battery of 2 dry cells connected in series. Each cell has an EMF of this and an internal resistance of this. This one you should know, or you should know how to get your total resistance and then total EMF from each of the cell. Then you can now use your formula to get your effective resistance of the bell. Don't forget that the bell is an external resistance, so you are looking for external resistance. Then you can now use it to find when the cells are connected in parallel. So I've given you the hints. So please try, go through this question, and if you have any challenge, let us know through our WhatsApp number. So guys, thank you so much. That is where we are ending that class, and we appreciate you for being with us. Please, if you have not subscribed, please subscribe on click on the subscribe button. Click on the notification bell so that when we upload a new video, YouTube will notify you. Thank you for your time, and we hope to see you in our next class.